Hey everyone, Doug here, and today I'm going to be taking a look at this really exciting new release from Lightricks, who are the makers of LTX. So, for those who aren't familiar, LTX 2.3 is one of the first AI video models out right now that will support native HDR output, which means instead of getting that standard 8-bit SDR footage, you're actually going to be getting scene linear EXR files that hold up in high end production tools like Nuke or DaVinci Resolve. Now, why am I so excited to present to you this? Well, it's because this is really the missing piece between AI video and a feature film finishing pipeline. Because we've been operating at this 8-bit ceiling. Every video generation model out there right now, really until now, has shipped out as 8-bit SDR. And that means 256 values baked per channel. It's locked in, it's how the models were trained, and it could not do any more data above that. That means no matter how good the AI video content looks on your YouTube or your phone, once it actually gets to final conform and gets to that the final color grading in a feature film or commercial pipeline, you're seeing artifacting like banding, clipped highlights. There's no range in the grading. And this was a thing, this was a hurdle that was preventing AI from really jumping in to that final production ready form that we've all been waiting for in the VFX space. Now, real quick, let's talk what HDR actually means. We're throwing out a lot of initialisms here, but HDR basically just means we've gone from the 8-bit 256 values per color channel to 16-bit HDR EXR, which means we are now at 65,000. That's a huge multiplier in the color precision that this LoRa unlocks for a production environment, which is just a huge thing. Now, how do they do this? Well, they did this very cleverly, actually. The model generates in log C3 compressed space, and it has this post decode inversion transform that expands it back to linear float. So this gives us that dynamic 16-bit range, and it's all encoded inside that normal numerical range during diffusion. So it was a really clever approach by the LTX team, and I really applaud their engineers. This was smart. So the pipeline works pretty simply. You pump in SDR, this IC LoRa transforms it through that log C3 linear decode we were talking about, and we output a 16-bit scene linear EXR with all of those 65,000 values that we are now just so excited about. So we're finally seeing generative AI kind of graduate into the production space with this EXR output format. This has been the default format for years and years and years. It actually comes out of the original HDR format. And this means that we've now finally closed the gap. We can generate our AI elements extremely quickly. We can then upscale them into project resolution, 4K, 6K, 8K, all the Ks. And then we can also now bake in and recover all of that pixel data that we were missing before. So as you can tell, I'm excited. Now, where can you get it? Well, it's over on the Hugging Face Lightricks page. Just go ahead and grab that HDR LoRa that we were talking about. And also, if you go over to the GitHub for Comfy UI, Lightricks, Comfy UI, LTX video, you're going to be getting the decode node. And I recommend that when you output these, make sure that you have a viewer. I'm going to be using Nuke in order to see that high range because the output's going to look weird. I'll show you that later. But there's so much data inside there. Ignore the weird. The weird is good. So you just grab this model, go ahead and drop it into your LoRa's folder, grab that HDR workflow. I'm going to show you what they've included from LTX. It's a nice little JSON file, and you will be off to the races to export that 16-bit EXR. You can bring it into Resolve or Nuke, and now you can deliver it to production at the production standards that we have been working at for decades now. All right, that's enough yapping. Let's jump in and let's see this really impressive LoRa in action. So first thing you're going to be doing is going over to their GitHub repo for Comfy UI LTX video. And this has everything that you're going to need to get up and running. We're going to be jumping between both Comfy Desktop, Comfy Cloud, and Blender and Nuke to compare all of our generations. But we got to start with the workflow. So you can find these workflows in this example workflow directory right here, and we're looking at this LTX 2.3 IC LoRa. So you're going to go ahead and you can either download it, or one of my favorite tricks is just coming over and hitting copy raw file. And now let's go ahead and jump over into Comfy. And this is what that JSON file looks like. So I think they could probably organize their node graph a little bit, just saying LTX, but it's not too bad. I'm just a stickler. But they gave me some footage to test to show this this in action. And the way this kind of plugs into the pipeline is, think of this as like another post process, right? It goes you can either go before, well, most likely after you're upscaling. So you're at show resolution, and then you can load it in here, and this looks fine. This looks like a really nice quality model. LTX 2.3 is one of my favorite video generation models, and this is a really good showcase of the quality that you can get. But if we jump over into Nuke over here, you're going to see very quickly that if we try and expose this down, well, there is no range. We start clipping really quick. And this is indicative of pretty much like every AI model out there. What they output looks really pretty on the RGB level, but the pixels break down. So jumping back over into this workflow, you simply just load in your video right here. So this will be your final generation. You're ready to go to full production. You're packaging up and sending it off to client. You'll load it up here, and you'll run it through a workflow like this. And let's go ahead and just click out and drag right there from the video file. And we're going to be outputting this into a, let's just go video LTX test HDR. We're going to say OK. Now, all that's left to do is hit run. But this is essentially it. So this is kind of what I think about as a final conform. Now, this is going to take a few minutes to generate. I'm running this locally, so this is going to be generating on a Dell that has a 6000 Blackwell GPU inside of it. It's a beast of a machine. It's what I use for all of my production work. And but even on this beast, it's going to take a few minutes. So we're going to edit this waiting period out, and I'm going to show you the results with the power of editing. All right, we got our result back, and let's see what we got. So we definitely have a lot more range here. This is looking odd because we have this exposure setting to 7.1. That's totally fine. Again, we're working with linear EXRs here, so it's not going to be displaying correctly, as this note over here says. So let's go ahead and jump over into Nuke one more time and check out what this actually looks like. So here, if you remember, we had our original image, and again, no range whatsoever. But let's go ahead and take that same exposure node and attach it to this image, which has much more range. And now we're seeing tons and tons of data added in. Now, this is what looks correct. This is what a floating point linear EXR is supposed to look like. And it gives you so much value in all of your pixels, because again, we're not working with 0 to 1 pixels here. We have pixels that are, as you can see down here, up to 42 and higher. This in comparison, when we actually mouse over this image, you again look at these little values down here. You can see we are clipped all 0 to 1. Again, this is just because of how the models were trained. They were trained on standard 8-bit images and low resolution as well. Well, this LoRa really is pretty great here. I'm very excited about this because, again, this is a huge gap in the VFX AI pipeline right now. That final conform. How do we get it to broadcast theatrical standards, right? This looks like we're doing that. So great job, Lightrix. Now, I want to see if we can push this a little bit further too, because we use this for final conform and delivery, but we also use HDRs in lighting. We will take what originally was called a light probe. This is just a high dynamic range HDR image, and we use it to light our CG objects. So back in the day, the University of Southern California produced a whole bunch of images to demonstrate the power of HDR. We're flashing back to the mid 2000s when all of this rolled out. And so I thought this would be a really great base test to see if we can take one of these HDRs or EXRs right here. We're going to download a few of these and load them into Nuke. And we're going to output standard PNG files. So we're going to get rid of all of the range, but we're still going to have a really good basis to test off of. So I've selected each one of these, and let's go ahead and just start with the Grace new test. So I'm just making a write node, and we're going to be outputting a PNG file. And again, this is going to strip down all of the range right here. And what we're going to be doing is we're going to do a little trick. I'm going to show you a little trick here. We're going to jump over into Comfy Cloud, and I'm loading in LTX 2.3 image to video template. You can find this by clicking over in the templates section and simply typing LTX, and all of the LTX models come through here. So we're going to be using this image to video model because again, this HDR workflow currently only works for video files. So we're going to just trick it. So I'm loading in our PNG file with very little range here. I'm plugging that image into Google Gemini to just simply tell it, describe this image, and we're going to pump that prompt right into the LTX 2.3 image to video subgraph here. And let's go ahead and produce this. And I'm setting my duration to 1. So let's go ahead and click go. And here is our result. So it's taken that base image, and it has basically just made has a little bit of a wobble to it, but that's totally fine because all we're going to need is one frame of this. So we're going to go ahead, and I'm not changing anything about this workflow, just plugging it in right there, and we're going to hit go. Just be aware that this is now going to overwrite frames. So if you want to save a series of these tests, I suggest you make a bunch of different subfolders. And wow, that was fast. Okay, I'm impressed with my Dell and this LoRa, my goodness. So let's go ahead and here, mute that. And again, we have a very clipped range right here. So the color looks all off, but that looks like a pretty good, it looks like we got range there. Okay, let's go ahead and now bring this first frame of this EXR back into Nuke and check it out. And here you can see our EXRs. We're going to load that up. And again, we're only going to need one frame of this for what I want to do next. But let's go ahead and check out that range. And that looks pretty darn good to me. We can compare it to the original EXR that, again, we got from the University of Southern California database. And you can see it looks like it's maintaining, it's taking that PNG file and put all sorts of really nice range into that. So that's extremely impressive. So what can we do with this now? Well, we can grab one of these frames and let's go ahead and just output a HDR. We're just going to call this Grace new HDR, and we're going to hit that .hdr button. We're going to hit render. We only want one frame, and we're going to hit go. And there we go. I've gone ahead and outputted that HDR and loaded up a little test scene in Blender over here to test this against, again, our control source of that University of California Grace source. So I have a point light here. Let's go ahead and we're going to disable that. And let's go ahead and plug this HDR value in. Now you're going to see I have this hue saturation value here, as well as a background strength knob for both of our control and our synthetic HDR is what I'm going to call it. This is just to give us some control because I'm not expecting this to be one-to-one. When we're dealing with floating pixel data, expect little things that are not perfectly similar. But let's see if we have something usable. So let's go ahead and plug in our base image. So again, this is our control test, and this is what I would expect to see. So we can go ahead and let's go ahead and we can rotate it. You can see this is the power of HDR lighting. Just rotate it and you get totally new lighting sources, right? So very, very cool. Now let's see what this looks like with our synthetic one. And that's pretty close. So again, if we kind of A/B these kind of roughly, you can see, honestly, I'm getting more color range in the LTX synthetic. I'm seeing a little bit of blues coming from those blue skylights that we have there. And the one from Southern California, I'm just basically getting like a wash of color. We can reduce the value, the intensity of this with this background strength knob. That's probably going to be helpful. But that's actually very impressive. So I'm also increasing the saturation here a little bit. Let's go ahead and put this down to 1. But you can see I'm still getting a lot of that color bleed, which is really, really nice. So now we have the power to not only output uh, high dynamic range images, taking our AI outputs and giving them range for final conform, but you can also produce synthetic HDRs that you can then bring into your CG lighting package of choice and actually get a huge jumpstart in integrating these into a real world scene, which is really kind of VFX 101 when you're in CG lighting. So I sent off a couple renders there just so we can kind of see this in out of that preview mode, and ignore the blocky reflections there. That's just a Blender setting that I didn't want to turn off because I wanted this to be fast. But here's our LTX and here's our HDR. So again, I'm getting a lot of really pretty color variation from LTX that I'm not getting from our ground truth, our base true HDR light probe from University of Southern California. So I'm pretty impressed. This is a really big advancement that LTX has put out there into the industry, and I'm really excited to see this being put to use because again, this was a huge blind spot with AI VFX production. We had no way of getting all of the pixel range that are required for certain vendors like Netflix or Disney, things like that. So, very good job, LTX. I'm very impressed with this model. This LoRa is out live now. As you can see here, it's right here in their main Lightricks Hugging Face page. So this is the one I'm testing right here. Is the 2.3 22 billion parameter IC LoRa. So go ahead and grab that. Grab your workflow from the Lightricks GitHub to test this out for yourself. And thank you so much for Lightricks for reaching out and letting me test out this new LoRa. I think it's a really important part of the VFX pipeline that we're going to be seeing a lot of really exciting development going on in the next few months to full year of 2026. So kudos to what they produced here. It's really impressive, and I really encourage you all to check it out. All right, I'm Doug, and until next time, I'll see you later.